Hello students, today we'll see some equations of electric energy. Equations of electric energy. What is electric energy? This is the energy or the work done by electric current. So how much work is done? The amount of energy that is supplied to the circuit will do the work. So energy will be equal to the work done. And let's see some equations of electric energy. The first equation, we know that electric energy E equals to VIT. Electric energy equals to VIT, where V is the potential difference, I is the current, and time in which the current is flowed in the circuit. So this is the product of V into I into T. So we can derive different equations from this base or root equation. So this is the equation for electric energy. This is equation 1. Similarly, from this equation we can also find another equation wherever we need, suppose we don't have the potential energy or I or T, so we can change the formula. We can change put some other values in place of these values. Suppose in place of V we can take I into R, because according to Ohm's law states that potential difference is the product of current and resistance. Hence in place of V we can put IR. In place of V we can put IR. So IR into I to T. Then from this equation we can get E equals to I square RT. This is our second equation. Again, if we want to eliminate I from this equation, what can be done? Again, following the Ohm's law, I will be V by R. Then in place of I we can put V square by R square. V square upon I square into R into T. Here this can be cut. We can get E electric energy will be equal to, this electric energy will be equal to V square upon R into T. So V square R into T. So this can be our third equation. So all these three equations can be put to get the answer or to solve the numerical problems on this electric energy. And it is kept in mind that electric energy is the amount of work done, or we may require this in case of in some problems related to joule heating. Again, these equations can be very useful in finding electric energy. I think these equations are helpful for class 10 students. Students now discuss related to this electric energy. We will now discuss about the power, electric power, and we know that electric power, or power in simple words is the rate of doing work. Power is the rate of doing work, that is W by T. We know from the above, from the previous studies, we know that power, electric power. Now we'll discuss electric power. Electric power. So it is the rate of doing work or rate of consumption of energy. We can also say that power is the rate of consumption of energy. And we know that P, so this gives the rate at which energy is dissipated or consumed. Energy is consumed. Energy, the rate at which energy is consumed. Energy is consumed. The rate at which energy is consumed or dissipated in an electric circuit. This is also termed as electric power. We can term it as electric power. So power P is given by, there is an equation, power P is given by the product of current and potential difference. Current and potential difference. So this can be also written as V, as we know, V equals to IR. From Ohm's law, very useful. We know that from Ohm's law, we know V equals to IR. So in place of V, we can put IR into I. So this can be I square R. I square R. So P can be I square R. And again, I equals to V by R. Then in place of I, V square by R square into R. So here we can get P equals to V square by R, V square upon R. So as per the definition, so it is the rate of, this is the square of potential difference and potential difference upon the resistance. Power can be the square of potential difference upon resistance. This is very useful when we find the power. This equation very useful. P equals to V square upon R. Students, we can define 1 watt power of 1 watt when 1 ampere of current, when 1 watt power is consumed, when 1 ampere of current is operated at a potential difference of 1 volt. Potential difference of 1 volt, we can write its equation that 1 watt is the power when 1 volt is operated 1 ampere of current, in 1 ampere of current. So 1 watt equals to 1 VA, 1 volt into 1 ampere. Thus the watt is the, here we need to remember that watt is the unit of power, SI unit of power, that is the rate of doing work. So let's now discuss what is the commercial unit of power that we use in our domestic supplies and also in the commercial sections. Also electricity is used and it is measuring unit is in kilowatt, not in watt. Watt is a very small quantity of electricity. Therefore, in actual practice, we used a larger unit, that is kilowatt. So that is the 1,000 times of what we know. Kilo is 1,000 times, since electrical energy is the product of power and time. Electrical energy is the product of power and time. Its unit will be kilowatt hour. Its unit will be kilowatt hour. So we can write as 1 kilowatt hour will be how much? That is 1000 watt into 1 hour is 3600 second, 3600 seconds. So this is one unit or 1 kilowatt hour. That can be written as 3.6 into 10 to the power 10 to the power 6 10 to the power 6, approximately 10 to the power 6 watt into second. That is how much? 3.6 into 10 to the power 6 watt second is joule. Remember that for any kind of energy, the SI unit is joule. So for electric energy, it is also joule. Students, now let's discuss a problem related to this electric unit, commercial unit, and what will be the bill for when a device is run for some hours in a day, and and also per the month. What is the monthly bill of this? How can we calculate? Suppose in the problem we are given, say an electric motor. It's uh, current, it takes current or draws current 5 ampere. Current is given 5 ampere, and it draws from a current supply or potential difference supply of 220 volt. So V equals to 220 volt. So there is a current supply of 220 volt. Let's calculate what is the power of the motor and energy consumed in a month. So we need to find power and energy consumed. Let's see what will be the power of this electric motor, and the time is given, that is this electric motor runs 2 hours a day. 2 hours. So time is 2 hours. 2 hours a day it runs, and what is the current, or what is the power consumed by it in the entire month? That is 30 days. Let's see. We know that power P equals to V, product of potential difference and current. Is the product of potential difference and current. So here potential difference is given, that is 5, and current is given 220 volt. So this becomes 1100, this much watt. So what will be the energy? E equals to, we know that from the above discussion we know that V, I and T is the product of potential difference, current and time. duration of the current flow, that is time. We can write it P into T, because P equals to Vi. P equals to Vi, so we can write P into T. So let's put the value. We have got P is 1100 and T here, the T is for 2 hours. If we convert it into 36 into 1 hour is 3600 into 2, that is 7200, yes, this much second. So 1100 into 7200, that is you can calculate it, 7.92 into 10 to the power 6 joule, 10 to the power 6 joule. This much will be the current energy drawn by it in 2 hours, and we can multiply it with 30 days, and we can get the what is the total monthly consumption of energy, and we can convert it into. So this is how you can calculate the value and of value of energy from power, and you can also calculate or by multiplying it with the rate of the charges by the electric supplier per unit. Unit means we know that it is kilowatt hour, and per kilowatt hour how much they charge it, and just multiply it and get it. Hope this video is helpful. Thank you.